All right, with chapter 6-4, we're going to look at the properties of rhombuses, rectangles, and squares. So we're actually going to start by defining those three terms. And then just like with sections 2 and 3, we talked about properties of parallelograms, and then we turned it around and said, if these things are true, then it's a parallelogram. We're going to do the same thing with sections 4 and 5. With 4, we're going to say, here's a rhombus, a rectangle, and a square, and these are the properties of each. And with section 5, we'll say, if these things are true, then we can identify it as either a rhombus, rectangle, or square. So they're going to kind of work hand in hand that way. So our first table here with our key concepts really goes over these definitions. So it's a key point and something you're going to want to keep handy as you go throughout your homework assignments for these chapters. So these are just our definitions. And we're going to continue to learn more about each of these three terms throughout the rest of the lesson. This is the definition of each. So a rhombus is a parallelogram with 4 congruent sides. So notice, and you're actually going to see this for all three terms, in order to have a rhombus, it first has to be a parallelogram. We have to know that opposite sides are parallel, or opposite sides are congruent, or opposite angles are congruent, or consecutive angles are supplementary. Any of those things we talked about in sections 2 and 3 to create a parallelogram have to also be true. Then we're going to go one step further and we're going to say not only is this a parallelogram, but all 4 sides are congruent. And that's what we have as a rhombus. I like to think of a rhombus as kind of like side of a barn that's falling over, an old barn falling over. All 4 sides are congruent. Sometimes we think of these as diamonds, but our geometric term is going to be rhombus. A rectangle then, again, we're looking at a parallelogram, and by definition, our rectangle is that parallelogram with 4 right angles. So all of those things about parallelograms are true. Opposite sides are still congruent. We know now, since it's all right angles, opposite angles are congruent, consecutive angles are supplementary, and we have those 4 right angles. That's what justifies our rectangle. And lastly, a square. Again, we're talking about a parallelogram, and this parallelogram has to have 4 congruent sides and 4 right angles. So notice square, and we're going to see that right down here in this nice little Venn diagram, is what happens if we have a parallelogram that falls under the category for rhombus and rectangle. If a parallelogram is both a rhombus and a rectangle, then it meets our definition for square. All sides congruent, all right angles. So we're going to spend the bulk of this chapter, or the bulk of this section rather, looking at different properties of each of these special parallelograms, and then identifying which parallelogram we have. Be warned in this section, in our homework, in the worksheet, that just because something looks like it might be a rectangle, if it doesn't meet the properties, we can't define it as a rectangle. So don't just look at it and automatically name it based on what it looks like. Make sure that it meets those properties. All right, so for problem 1, we're going to be identifying both of the parallelograms we see here. The first part asks us to look at parallelogram ABCD and identify it as a rhombus, a rectangle, or a square, and explain. Now, notice this right here. This little symbol we talked about in section 2 is our abbreviation for parallelogram. That's telling me that kind of my outside parallelogram here, ABCD, you can see in yellow, is a parallelogram. It's telling me opposite sides are congruent and opposite angles are congruent, and that consecutive angles are supplementary. So we already know all of that. Now, in addition to that, we see that angle B is a right angle. That alone does not satisfy our definition for any of those terms we just talked about. But if we think about what we know about our parallelograms, if angle B is a right angle, then angle D is also a right angle, since opposite angles in a parallelogram are congruent. Now, another thing we know about angles in a parallelogram is that consecutive angles are supplementary, meaning they have a sum of 180 degrees. So in this case, for example, A and B are supplementary. They must add up to 180 degrees. Well, since B is 90 degrees, A must also be 90 degrees in order to give us a sum of 180. And lastly, calling back on what we talked about in the beginning, opposite angles are congruent. Now that I know the measure of angle A is 90, measure of angle C is also 90. Now, looking at our picture, we've taken this parallelogram ABCD and identified that it has 4 right angles. If we go back to our definitions of these special parallelograms, a parallelogram with 4 right angles is defined to be a rectangle. So in this case, I would identify ABCD as a rectangle. Now, if we know it's a rectangle, we always just want to do a quick double check to make sure it's not also a rhombus, because we know if it's a rectangle and a rhombus, we have a special term for it, and it's a square. In order to be a rhombus, we'd have to know that all sides are congruent. In this case, I'm not given any information about the sides of parallelogram or rectangle ABCD, so I'm going to go ahead and stop there with calling it a rectangle. I don't know enough to call it to call it a rhombus and then a square. Our next problem, we're going to still look at the same picture. But this time we're told that we're told that we have parallelogram EFGH, and we want to identify it as either rhombus, rectangle, or square. Same type of concept. Now we're looking at this inside figure. Oh, that's not going to work. In my picture, highlighting it doesn't do a whole lot. Now, again, this is a parallelogram. We know that because we're told that with that parallelogram symbol. So all those same conditions for parallelograms apply. So opposite sides are congruent. So I know that EH has to be congruent to FG. Well, if EH is congruent to FG, then FG is going to be marked with 1 tick mark, since that's what we see on side EH. And same is true for EF and HG. EF and HG must be congruent since they're opposite sides of the parallelogram. Now, notice since EH and EF, these kind of top left and top right sides were congruent, and by marking their opposite sides congruent to them, we've marked all 4 sides congruent. So I'm going to just jot down that note. Oh, that's not HG, should be the last one. So now, knowing that all 4 sides are congruent, if we look back up at our definition for special parallelograms, notice that the definition for rhombus is a parallelogram with 4 congruent sides. So we've just found that parallelogram EFGH is a rhombus. And again, you always want to go one step further and see if it's also a rectangle to then identify it as a square. Notice in this case, I don't know anything about the angles. In order to be rectangle, I have to know I have right angles. I've got no angle markings on EFGH. I'm not given any information about the angles, so we're going to stop there with just calling it a rhombus. So we've learned about the definitions of those 3 special parallelograms, but there's more to it than just what's in the definition. So just like with our parallelogram, how we said, hey, the definition of a parallelogram is that opposite sides are parallel, but we also know all these other great things. Opposite sides are also congruent, opposite angles are congruent, consecutive angles are supplementary. The same is true for these special parallelograms. We know more than just what our definition tells us. So this first 2 talk about some special things we know about rhombuses. The first one says, if a parallelogram is a rhombus, then its diagonals are perpendicular. Meaning, the diagonals are going to intersect at a 90-degree angle. So here's my rhombus, ABCD, in this first picture here. They've drawn in the diagonals. Remember, diagonals are segments that connect non-consecutive vertices, so AC and BD are my diagonals, and they intersect at a 90-degree angle. They are perpendicular. That's going to be true anytime you're looking at a rhombus. One thing I do want to make note of, and you can see it here in this picture, notice my diagonals are not congruent here. AC is not the same length as BD. It's longer from B to D than it is to A to C. Just kind of keep that in the back of your mind. Now, the other thing we know to be true about the diagonals of a rhombus is that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles, meaning each diagonal becomes an angle bisector. So in this case, AC is my angle bisector, or excuse me, AC is my diagonal. It also bisects angles A and C. So it cuts angle A into two congruent angles, 1 congruent to 2. It cuts angle C into 2 congruent angles, 5 congruent to 6. Same is true for my other diagonal. Diagonal BD is an angle bisector for angle B and D. 3 congruent to 4, 7 congruent to 8. Now, let's extend on this for a second here, and then we'll bring this into play in our next example. We know, since it's a rhombus, it's a parallelogram. And we know, since it's a parallelogram, that opposite angles are congruent. So all of angle A has to equal all of angle C. So when they get bisected, they're actually going to still be creating congruent angles. So not only is 1 congruent to 2, but it's also congruent to 6 and 5. All 4 of these angles will have equal measure. Same is true with my other set of angles. 7 and 8 are congruent to 3 and 4. So by drawing in those diagonals, which become the angle bisectors, we've just created 2 different pairs, or excuse me, 2 different sets of 4 congruent angles. Okay? So in your worksheet and your homework assignment, you're going to see some pictures like this where you're asked to find other angle measures. And in this case, we're actually only given 1 angle measure. We can find all of these others, and they're labeled here 1, 2, 3, and 4. Now, please make note, you won't always be able to find these in numerical order, 1, 2, 3, then 4. Just find them in the order that makes sense to you. You might need to know 3 before you can find 2, for example. All right, so we've got, it asks us to find the measures of the numbered angles in rhombus ABCD. So they're telling us this is a rhombus. So we know that all the sides are congruent. We know that the diagonals are perpendicular, and we know that the diagonals become angle bisectors. So I'm going to start with that second thing I just said. The diagonals are perpendicular. That means where they intersect, it's a 90-degree angle, which is true for all 4 of those angles it creates. So right away I can tell you angle 1 is equal to 90 degrees. Anytime you're looking at a rhombus, wherever that intersection of those diagonals is going to be 90 degrees. Okay. Now remember what we talked about when we looked at the angle bisectors. Since BD is a diagonal, it's cutting this angle in half, which means this angle here is also 58 degrees. And we said since we know opposite angles are congruent in a parallelogram, it's also made 2 and 3 be congruent to to these top angles with angle B. So angle 2 and angle 3 are also 58 degrees. And to find that, we use the fact that opposite angles are congruent and that the diagonals of a rhombus are angle bisectors. Now to find this last angle, angle 4, I'm just going to kind of redraw here. Notice we've got a triangle that's made between A, D, and the intersection of my bisectors. And we already said that, the intersection of my diagonals. We already said that the intersection of those diagonals are 90 degrees. That's where angle 1 was. And I just found that this angle down here, where angle 3 was 58 degrees. So if I want to find measure of angle 4, I'm going to use triangle sum. 180 minus 90 minus 58 will give me the measure of angle 4. 180 minus 90 minus 58 is 32 degrees. So the measure of angle 4 is 32 degrees. Now you're going to see more of these pop up. They're going to not always follow the exact same format, but you will frequently use things like triangle sum. You may have to use alternate interior, alternate exterior, or same side interior angles. So if you need to review those from earlier last semester, make sure you do that. Use the fact that those diagonals are perpendicular and angle bisectors. So that's rhombuses. For squares, we know that if we're looking at a square, then the diagonals are congruent. So remember how we looked at the diagonals of rhombuses, and I said just remember, notice that it's a lot longer from B to D than it is from A to C. Or maybe that was the other way around. Let me look. Yeah, that was right. Well, that's not the case for the diagonals of my rectangle. In a rectangle, if I have 4 right angles, it's going to be the same distance from A to C as it is from B to D. So that's what we know about the diagonals of our rectangle. Our example, problem 3, says we've got this rectangle RSBF, and I know the length of SF is equal to this expression 2x plus 15, and the length of RB is equal to the expression 5x minus 12. So now I want to know what the length of those diagonals are. Well, using that theorem we just looked at, theorem 6-15, we know the diagonals have to be congruent since it's a rectangle. Which means SF, the length of SF, is the same length as BR. Now use your substitution. SF is 2x plus 15. BR is 5x minus 12. One equation, one variable we can solve. Start by moving our x's to the same side. I'm going to subtract 2x from both sides. 15 is equal to 3x minus 12. Add 12 to both sides. And 27 is equal to 3x. Divide both sides by 3. And x is equal to 9. Now, be careful. I'm not asked just to find x in this case. I'm asked to find the length of the diagonal. So don't stop once you find x. Plug that value of x back into either diagonal. We're going to do both just to double check that we've got our work right. So 2, replace x with 9 plus 15. 2 times 9 is 18. 18 plus 15 is 33. So SF has a length of 33. We can do the same for RB just as a really quick double check. Plug in 9 again for x. So 5 times 9 minus 12. 5 times 9 is 45 minus 12. There's that length of 33 again. We've double checked that we did our algebra correctly. So by knowing the diagonals are congruent, we're able to identify the length of each. So this last one, we're just going to go back to looking at now what we know about the properties of rectangles and rhombuses and our definitions and identify which each of these figures are. Again, we're told that it's a parallelogram. So we know that we at least have those properties of parallelograms to be true. Then we want to decide if it's a rhombus, a rectangle, or a square. So let's start by looking at number 1. And I'm noticing here that this top side is marked congruent to the right side. And again, this is like that kind of second example we did today. Since it's a parallelogram, opposite sides are still congruent. So the top and bottom have to be congruent. So I'm going to mark the bottom with 1 marking, and the left and the right have to be congruent. So since the right is marked with 1 tick mark, I'm going to mark the left with 1 tick mark. Notice I've just marked all 4 sides congruent. So this is a rhombus. Don't stop there. Always double check if it's also a rectangle. Notice I've got a right angle up here in the upper right hand corner. Since opposite sides in a parallelogram, since opposite angles in a parallelogram are congruent, I'm going to have a right angle down here. Since consecutive angles are supplementary, the angle on the bottom left and the top left have to add up to 180, meaning this one has to also be a 90-degree angle, and this one has to be a 90-degree angle. So this parallelogram is also a rectangle. If you identify a parallelogram to be both a rectangle and a rhombus, then we have a square. We always want to be as specific as we can. So just telling me rectangle or rhombus would not be sufficient. Make sure that you identify it as both, and then we name that a square. And our last example here, you could tell right away I've got these all 4 sides marked congruent. So I know right off the bat, by definition of a rhombus, this is a rhombus. I just need to check if it's also a rectangle to become a square. I know the bottom angle here is 130, so I'm going to mark the top angle as also 130 using my properties of parallelograms. And then I know that consecutive angles are supplementary, meaning this angle has to be 50 degrees so that those two add up to 180. And then this one is also 50. I've just identified that I do not have 4 right angles, so this is just a rhombus. So you'll spend some more time in your homework problems practicing these properties. You'll want to make sure that you're familiar with both the definition and those theorems that we came up with. If you have questions, please let me know.